Greetings everyone. This is the tail end of the section 2.4 lecture that I would have done on Friday if I had been able to be in class. We have two problems to finish up, starting with this problem number 6. A quadratic function has exactly one x-intercept at x equals 2 and opens downward. So we're supposed to make up that function. That means what would the equation be? Well, first off, I'm going to draw a picture of what the given information is telling. It has exactly one x-intercept at x equals 2. And it opens downward. Since it has exactly one x-intercept, that must be the vertex. So the graph looks something like that. Well, we want to write something about the formula. We know that since it opens downward, the coefficient a is negative. A is less than 0. We know that since we have exactly one x-intercept, and that's the vertex, then the formula is going to have to look something like f of x equals Ra x minus h squared plus k. Exactly one x-intercept means that k is 0. Because if k is 0, that means that we have the vertex right on the x-axis. Now, the h is the x-coordinate for the vertex. And the x-coordinate from our graph is 2. So h has to be 2. So we now know that we have x minus 2 squared plus 0. And we know that this has to be negative. So it doesn't tell us any other information about what a could be. So a could be a negative 1/2. A could be a negative 50. We could have a graph that looks like this. If a were, say, larger in magnitude than what we originally drew, or if a were less in magnitude, you could have this. So, in other words, we're answering the second question here. There could be, in fact, there are infinitely many solutions. Now, here, a solution means a choice for the function f. We could satisfy the demand of the problem by saying a is negative 2. Just pick one. Of course, your friend could have said, or f of x equals negative 42 x minus 2. I'm assuming that your friend is a fan of Douglas Adams. Whatever we choose, the coefficient a does have to be negative, like we said above.